In this video, we're going to get started on calculus. It's a pretty big thing to get into, so we'll take baby steps in these videos, in these short videos. So, limits are going to be what we're first going to learn. They're one of the most basic parts of calculus. We can kind of compare limits to functions. This function over here is called a parabola. And this is a parent parabola because we know that it's f x equals x squared. And how does this relate to limits? We'll get to that soon. So we can plug things into these functions. For example, if we plug in 2. And if we plug in 2, that would give us x, which would be 2 now, squared, and we all know that 2 squared is 4. Now, this is how to plug in with a function. We should already know that. But now let's get into something new. Let's kind of format this into a limit. So this is how to format a limit. The limit of x approaching to 2, x squared equals 4. Now, what do each parts mean? So we all recognize this part, that's the function. We all recognize this part, that is the result, or solution. Now, here gets the interesting part. This is what notifies this as a limit. So we're telling the person that this is a limit that we're taking here. And this is the part that says x is approaching to 2. Let me tell you what it means. So when x is extremely close to 2, when x is extremely close to 2, over here, it's not exactly 2, but it's close enough that it's almost as if it is 2, but remember, it's not exactly 2. So it's close enough, x is approaching 2, and it's so close that although the result is equal, the value is still not 2. Let me show you how this can be useful. If we have a hole right there, a gap, if we plug in the value of 2, it would return an error because there's a hole there right on the exact spot. But then if we take a limit, it's still going to return 4 because it's not exactly 2, which means that it will miss the hole, but it's close enough to 2 that it'll still return an accurate result. Okay, now let's get on to another problem, another value or thing about limits. So here, last time we were approaching the value, we were approaching the value from both sides. What do I mean from that? Is that we're coming from 3 to 2.5 to 2.2 to 2.1 to 2.00001, and from 1.9, 1.9, 1.99999. So we're approaching from both sides that are going to be equal to 2. That's what a limit is. But when we have a problem like this, if we approach from both sides, we don't exactly know which value we're going to snap to. And of course, we know that if plugging in a value like this with the standard method will also return an error. So now I'm going to introduce something new. So we know this, the lim of x approaching to 2, but then there's going to be something next to the 2, a plus sign. This is going to be called a right-handed limit. It means that we're approaching from only, that means we're going to be approaching from only the right side, whereas here we approach from the right side and the left side. So now that we know the side we're coming from, then we can go to here, which is 4. And likewise, if we approach it to 2 from the left-hand side, with a negative sign, then we would get 2. So this has been an introductory lesson on limits. In the next video, we're going to show you how limits can be actually solved.